This video is about baselines and anomalies and why they're so important in cybersecurity. A lot of the content is based off of this TryHackMe room, and I cannot recommend this enough. TryHackMe is an amazing resource. It only costs 10 or 12 pounds a month. I 100% recommend them. Okay, let's get started. Imagine a person, Bob, has a routine. He wakes up at 5, walks his dog at 6, drives to work at 7, starts working at 8, has his lunch at 12, gets back to work at 1, drives home at 4, and then sleeps at 9. And Bob does this on all weekdays, right? This behavior from Bob is always expected from him and is his baseline. Any deviation from this will be considered an anomaly. Some anomalies are expected. For example, Bob may go on vacation, and on those days he may not follow this routine. But if he lets his coworkers know well in advance, then that wouldn't be suspicious. But some anomalies could be unexpected. For example, if I go to the mall on a random Monday morning and run into Bob at 11 a.m., that would be suspicious, as Bob should have been at work, and that would then be investigated. Now, what's important to note here is that it would only be possible to identify these anomalies if you knew the baseline. And this is very important in cybersecurity. It's very important to know what normal behavior of the assets and environment you're protecting looks like. And it's good practice to have baselines for your hardware inventory, network traffic, identity and access management, and software inventory. Hardware can be considered the basic building block of a company's network. It is essential to create an inventory of the hardware assets. An ideal inventory will consist of the hardware's name, asset type, location, purpose, its operating system, owner's name and contact details, and any other helpful information. Some companies use dedicated asset management tools for this, but if you don't have access to one, you can create a simple spreadsheet and maintain a list of inventory. Following a naming convention for your assets is good practice, and as your inventory grows, you will appreciate having naming convention in place, as it would be easier to understand the purpose of the asset. For example, these two assets indicate they're located in Great Britain, workstation or server, that they're virtual machines, their unique IDs, and the environment that they belong in. The inventory could have workstations, could have servers. If servers, it's typical to have static IPs, and IP addresses could be recorded too. Maintaining a baseline hardware inventory is often not a one-time effort and will need constant updating. So some softwares can do this automatically to a certain extent, but if using a spreadsheet to maintain manually, then it's good to have an interval defined as to how frequently it would be updated, who would update and verify the inventory, and this will ensure as people leave or join, assets are reused for different purposes, new assets are onboarded, old assets are decommissioned, and the inventory stays up to date. Baselining network traffic. There are three main ways to identify anomalies in network traffic: having a communication matrix, checking proxy and DNS server activity, baselining ports, IP addresses, and MAC addresses. It's very common for companies to have different network zones like DMZ, trusted, restricted. The reason they do this is because it makes it easier to secure the network. Different zones will have different levels of security. For example, internet-facing servers will be in the DMZ, and it also helps isolate different parts of a network in the event of an outbreak. Certain defined communication matrices are created between these zones based on the organization's policies. For example, an internet-facing web server needs to be in the DMZ. Similarly, a web application that serves another purpose but is internet-facing will also be in the DMZ. Now, they both might be communicating with their backend servers, which will be located in the trusted or restricted zones. In normal circumstances, the web server will only communicate with a specific backend server on a specific port, and the web application will communicate with another different backend server on a different port. This allowed communication can be considered as a communication matrix. It's good practice to identify the required communication matrix and explicitly allow it. But it's a lot of work, and some companies may not want to do it. But having this information handy can be very important for defenders, because without the correct knowledge, attackers may violate the communication matrix. For example, if the attacker compromises the web application in the DMZ and wants to move past this to the trusted zone and the restricted zone, without the right knowledge, he might try to communicate with the web server's backend server instead of the web application. This will violate the expected communication matrix and trigger an alert. Proxy and DNS server activity. Zoning helps isolate networks, but sometimes assets in the networks need to talk to each other. For this purpose, internal DNS servers and proxy servers are set up. All internal DNS requests will be routed through internal DNS server, and any outgoing internet traffic would pass through a proxy server. Any deviation from this expected behavior, like attempts to bypass DNS or proxy server, would be an anomaly and then be investigated. Baselining ports, IP addresses, and MAC addresses. Another way to hunt for anomalies in a network is to baseline the ports, IP addresses, and MAC addresses in the network. IP ranges are often used for clusters of machines for a specific task or a specific application. This information can be used to identify if those same IP ranges are used for that purpose. For example, suppose all workstations in an enterprise network are present in this IP range. If we find any Windows Server OS in this IP range, it might be a cause for concern. A lot of times, this might just be a case of misconfiguration, but it might also help us identify threat actors. MAC addresses can also be used in a similar manner. If the organization is using dynamic IP addresses, we can map certain users with certain MAC addresses and try to identify if a certain user logs into a machine that does not belong to them. This might help us identify certain cases of lateral movement. Baselining IDAM, or Identity and Access Management, can be done to identify normal user login activity and abnormal identity events. Users often perform the same type of activity every day. Once some anomalous activity is observed from a user, we can verify the activity with the user themselves to check if it's the user performing it or an attacker. You could check for anomalies by looking for impossible travel, unusual login times, unusual login machines, app usage, or SSO activity. An impossible travel security alert occurs when a user is detected logging into their account from two geographically distant locations in a very short time frame, making it physically impossible for them to travel between those locations. This alert helps identify potential account compromise or unauthorized access. Unusual login times. If everyone in the company works 9 to 5 and if a certain user logs in outside those working hours, then that's suspicious. Unusual login machines. I already covered this. If a user logs onto a machine that they don't usually use, that could indicate malicious activity. App usage or SSO activity. If the organization uses single sign-on, users will be using SSO to log into multiple enterprise apps. A baseline might be created for users accessing these applications. A user who does not need to access GitHub but is suddenly logging into it might mean that the user account is compromised and needs to be investigated. Baselining software inventory. In large companies, this could be challenging as different teams may have different software that they use on a daily basis. Network monitoring and tools to connect to other systems like Wireshark and TeamViewer may be used by the networks team, and that's perfectly normal. However, anyone in finance or HR using these would raise suspicion. To create a software baseline, software of general use by all departments would need to be collected. Ideally, each team will provide this input. Mostly though, IT teams are the only ones with permission to install or delete any software. Any team needing to install software must send their request to IT, then a risk assessment would be performed on the software, and an inventory is maintained before installing it. There will be two categories in the software inventory. The first will be software used by all teams, such as browsers, email clients, antivirus software, etc. Secondly, some software only required by specific teams. One way to enforce this is by application allow listing. This can be done using App Locker on Windows. This tool would only execute certain allowed applications. Allow listing can be done on a per user, per group, and company-wide basis. Attempts to run applications not in the allow list could also be logged and investigated. Golden images can also help ensure that a company uses the same baseline image of the operating system and the commonly used applications. Golden images are, in effect, the software and configuration baselines for an environment. It will contain all the basic software installed and configured in a dedicated image, which will be used to build all the computers in the organization. There can be separate golden images for end-user machines, Linux servers, and Windows servers. Each of these golden images would have all the requisite software like EDR, log forwarder, and the configuration that helps join the Active Directory, IP addresses for the log forwarder, DNS configuration, etc. A golden image helps maintain consistency throughout the environment. Similarly, if a system is compromised and once the attack is contained, golden images help recover quickly since all the secure baseline and configuration are ready to be implemented right away, instead of manually configuring each system. Advanced attackers nowadays use legitimate looking or legitimate software to achieve their goals using living off the land techniques. These are some ways you could identify and investigate these attempts. Examine masquerading legitimate processes. This will differ in each environment. However, some things are always going to be constant. For example, which OS binary is run from which specific directory, how many instances of that process should be running at a particular time, what user normally runs it, and what its parent binary should be. For example, many malware uses a malicious process with the name svchost.exe masquerading as a legitimate Windows process with the same name. Check parent-child relationships. Parent-child relationships are also important in the case of detecting lolbas. For example, legitimate Windows tool PowerShell could be misused by attackers. Suppose you see a PowerShell running some suspicious commands executed by MS Excel, which was executed by MS Outlook. You wouldn't be wrong to assume that this happened due to a malicious attachment from a phishing email. Differentiating from admin activity. Sometimes legit use of these binaries could be observed from admin activity, especially WMI or PowerShell. You will often see admin activity from processes like SCCM or other remote administration tools, but they would be run by administrators using specific user accounts from specific directories or with a specific parent process. It would be helpful to know these user accounts, directories, and parent processes and raise an alert if the lolbas is executed differently. The best way to confirm this activity would be by directly communicating with the admins to see if it was them performing this. A bonus resource that I've used a lot during investigations is lolbas project. It's a great resource that has information on how these binaries and scripts can be abused. I'll drop a link in the video description. Do check them out. Change management and approvals. In most organizations, change management processes will be in place that will ensure all admin activity is pre-approved and logged in a separate IT service management software. For example, if an access control list on a firewall needs to be changed, the network team will get it approved through the ITSM system. When the team performs this activity, they will add the ITSM ticket number in the comments of the change they make, making it easy to verify the reason for the change and for future reference as well. I hope you found this video useful. I will see you in the next one.